In this video, we're going to solve some chemistry practice problems. And my hope is to show you that you don't really need to memorize a lot of things to be able to solve these problems. Rather, you can solve most of these by relying on understanding a few fundamentals. Also, these problems do not cover the same topic, and this was done on purpose to make it similar to what you would encounter in an exam or a test. I highly suggest that you pause the video and try these problems on your own, and then you can play to see if you got it right or wrong. So let's get started. The first question asks us to predict the product, and usually for these kind of questions, I always start with identifying the functional groups that I have in my substrate. So here we have a double bond, and then looking at the reaction conditions. So we have mercury acetate, water, and THF, and the second step is sodium borohydride, which I know is a reducing reagent. So in introductory organic chemistry, whenever you see mercury acetate, the chances that it's usually used to add OH to a double bond. And the mechanism is not 100% known, I think, and that's why in most introductory classes you're not supposed to know the mechanism. But because I don't want you to memorize things, I will show you one simple way of thinking about this. So here we have mercury acetate, and I know this double bond is electron rich, so it's going to be my nucleophile. And the first step is that this is going to attack the mercury. We're going to kick off one of the acetates. And this is where it gets a little bit tricky because mercury also has lone pairs of electrons, so it's going to also attack one of these carbons, and this is how we get the bridge. So let's draw it. Oh, sorry, we lost one of the acetates. Okay, so one of the things that you should always look out for when you're drawing reaction mechanism is whether or not there's a stereocenter. So if I look closely, there's a stereocenter right here and right here. So this means that we could draw this intermediate as either like this, methyl group coming out of the page, and this is our hydrogen, or we can draw it like this. Okay, so always look out for generation of stereocenters. Now, in the next step, we have water floating around the solution, and that we know that can act as a nucleophile. So we have water. Okay. Now the question is this going to attack this carbon or this carbon? If it attacks the top carbon, then that means we're going to break this bond. And as this bond is being broken, there are some moments in the reaction that we're going to generate some partial positive charge here. If we attack the bottom carbon, we're going to break this bond, and again there's generation of partial positive charge here. Now looking at these two, so the top or the bottom carbon, which one do you think will be more stable with that partial positive charge? So the top carbon is going to be more stable because this is a secondary carbocation, whereas the bottom one, it's a primary one, so it's not going to be stable, and that's why water is going to attack the top carbon. So let me just erase this. Okay. Now, what type of reaction does this remind you? The red arrow and breaking this one. So this is similar to an SN2 reaction, and that's why we're going to generate that's why there's going to be an inversion of stereocenter. So if we continue this, there, sorry, inversion. So this is CH3 and H and our mercury. And if we do the same thing for this intermediate or this enantiomer, so we're going to get water, CH3, H, and mercury. Now you should always be careful of OH2 positive. This is not really stable or happy. So what happens is that because we have conjugate base around, it's just going to get deprotonated. And same thing for the second intermediate. Our second step is sodium borohydride. So again, this mechanism is not needed for most introductory chemistry classes. So you just need to know or probably remember that the second step is just to get rid of that mercury acetate. So NaBH4, this is our second step. We're just going to cleave off that and replace it with a hydrogen. And this is no longer a stereocenter. So that's our first question. Let's move on to the second one. Okay, so again, start off with identifying the functional groups. I can see that there's an alcohol here. I have HBr. So what do I know about HBr? Well, I can think of it like this. Br has a partial negative charge, partial positive charge. So this could act as an electrophile. Now, I know that HBr can add to alkenes, but we don't have any alkene here. I already identify an electrophile right here. So my next logical step would be to identify a nucleophile. So can you identify a nucleophile here? So this oxygen is going to be our nucleophile. It has lone pairs of electrons, going to attack that hydrogen, breaking that bond, and we're going to get this intermediate right here. I highly suggest that you write like bromide ion as one of the products so you know what you have in the solution. Okay, then I'm thinking, well, what's going to happen next? I have this OH2 plus. I know this is not stable or happy, so something must happen. If I deprotonate this, it just goes back to the substrate, so that's not really logical. What else do I know about OH2 plus? So other than ability to get obviously deprotonated, I know that this is a very good leaving group because it can just leave as water, and I know water is stable. So my next logical thing is that this should leave as a leaving group, and then the question is it an SN2 type of reaction or SN1 reaction? And by that I mean, does this bromide attack here and this leaves, or so 1, 2, or does water leave first? So is it this first? What do you think? So the way that I would look at this is the first thing to determine if it's an SN1 or SN2, or the easiest way is to determine if what kind of a carbon or substrate you have. So here we have a tertiary substrate. So this is tertiary, and I know that tertiary substrates usually do not go under SN2 reactions, rather they undergo SN1 reactions. For SN1 reactions, I know that there must be a generation of a carbocation. So that means that this is going to leave to give me the carbocation intermediate. And I know this is true because this is now tertiary carbocation, and I know tertiary carbocations are very stable. And so last step would be for bromine to attack here. And this gives us our final product. So again, last check, always when you draw products, make sure you're not generating any stereocenters. So here, this carbon is not a stereocenter because it's not attached to 4 different things. These 2 are the same. So that would be, there are no stereocenters or stereoisomers being formed. So this is an this is an SN1 reaction. Okay, so moving on to our last question. So again, start by identifying your functional groups. We have an alcohol here, and we have dichromate here. Again, in introductory chemistry course says whenever you see chromate, oh, I guess I already have the answer here, so let's just pretend that did not happen. So whenever you have chromate, it's usually oxidization of alcohols. And to give you a general idea of how this happens, so this is our alcohol, and the chromium can be in different forms, so I'm just gonna call these X. And the first step is that this is going to attack, something must leave, and this gives us this intermediate. Now what happens, and this is probably the most important point, is that a base is going to grab that hydrogen. We're going to break that bond. This guy will leave, and this is how we end up with our oxidized product. In this case, we have an aldehyde. So we went from an alcohol to an aldehyde. So this is what allows the oxidation to happen. So the carbon that's attached to OH directly must have at least 1 hydrogen for this to undergo oxidization. Now, if we look at our substrate, this is the carbon that's attached directly to our alcohol. Do we have any hydrogens? So if I go this way, this is a carbon, this is a carbon, this is a carbon. So no hydrogen is attached to this carbon. That means that no oxidation is going to happen, and this is a trick question, so nothing will happen. Tertiary alcohols, no oxidization. Alright, so these were all the questions I wanted to do in this video. I hope you enjoyed it. Let me know if you like more of these kind of practice problems.